Today we're going to continue with section 4.4, exponential and logarithmic equations. Today we are going to apply problems involving exponential and logarithmic equations. All right, so we are going to use the formula R equals C times e to the 12.77x power, where x is the blood alcohol concentration and R, given as a percent, is the risk of having a car accident. What blood alcohol concentration corresponds to a 50% risk of a car accident? Okay, so they're giving us the formula and we want to substitute in what we know. So once again, X is representing the blood alcohol concentration. That's what the problem is asking for us to find. It says what blood alcohol concentration corresponds, and then they're giving us a 50% risk. So R, which is given as a percent, is that risk of having a car accident. So that means that the 50% is going to go in for the R. All right, so we don't really have to write the percent since R is given as a percent. So we can just say that 50 equals 6 times e to the 12.77x power. And so now we want to start solving for x. And so that's why it's important to know how to solve an equation dealing with a variable in the exponent. So remember, the first step that we're going to do is we want to isolate that base that has the exponent by itself. Because there is a 6 being multiplied by it, that's the first thing that we're going to move. So I'm going to divide both sides by 6. Now, 50 divided by 6 is not going to be a whole number. So because it's going to be a repeating decimal, I'm going to just leave it as that fraction for right now. I mean, if you want, you could technically simplify down that fraction, but I'm just going to leave it as 50 over 6. Now that equals e raised to the 12.77x. And now that we have this base isolated by itself, we can go back and resort to what we've done in the past. I'm going to take the natural log of both sides. So we're going to have the natural log of this 50 divided by 6, and that's going to equal the natural log of e raised to the 12.77x. Now remember, natural log is log base e, and so because that is next to e, those are inverses, those are going to cancel. So we have the natural log of 50 divided by 6, and that now equals 12.77x. So the last step to get the x by itself, I'm going to divide both sides by 12.77. And then this is where we are going to very carefully type it into our calculator. So we'll type the natural log, we'll do 50 divided by 6, close the parenthesis, and then divide by 12.77. I'm going to have us round to the nearest hundredth, so 2 decimal places. So it looks like we get approximately 0.17. So that would be the blood alcohol concentration to get a 50% risk of a car accident. Okay, let's take a look at another example. It says the formula A equals 15.9 times e raised to the 0.0235t models the population of Florida, A, in millions, t years after 2000. So in part A, it says, what is the population of Florida in 2000? Okay, so if this model that is given to us represents t years after 2000, that means the year 2000 is the starting point. That's 0. Okay, so I'm going to plug 0 in for t. And so notice that 0 times that decimal is going to be 0. Anything raised to the power of 0 will be 1. So that means that 15.9 is getting multiplied by 1. So that means that we will have a population of 15.9. And remember, A is in millions. So that's my starting point. In 2000, there are 15.9 million, I guess I don't need an S at the end, million people. Okay, in part B, when will the population of Florida reach 19.2 million? Okay, so essentially what they're giving me now is they're giving me the value for A, and we want to work backwards and we want to find T. Okay, T is going to help us get the year. So I'm going to take 19.2 and set that equal to 15.9 times e raised to the 0.0235 t. Okay, so just like the last example, we want to isolate that base of e by itself. Right now there's a 15.9 that's being multiplied, so I'm going to undo that multiplication by dividing. Hopefully we notice that 19.2 divided by 15.9 is not going to be the nicest number, so I'm just going to leave it as that fraction for right now. So we'll have this 19.2 over 15.9. Now that's going to equal e raised to that 0.0235t. Now that I've isolated that base, I'm going to take the natural log of both sides. So we'll have the natural log of 19.2 divided by 15.9, and that's going to equal the natural log of e raised to this 0.0235t. So once again, natural log and e are inverses. Those are going to cancel. So that leaves us then with the left side equaling 0.0235t. So the last step to solve for t is to divide by that 0.0235. And once again, we're going to very, very carefully type this into our calculator. So we're going to have natural log 19.2 divided by 15.9, close the parenthesis, and then divide by that 0.0235. And so it looks like we're approximately 8.03 years. Okay, so that means that we're approximately 8 years after 2000. So 2000 plus 8 would be that in 2008, we have that population of 19.2 million. Okay, so it says let's use the formula A equals P times 1 plus R over N raised to the NT power. Hopefully that looks familiar. Remember, that was our compound interest formula. We're going to find the time t in years given this information. So the amount invested is 7,250. So remember, if it's invested, that's your starting point. So that's P. We're compounding monthly. So remember, there are 12 months in a year. So that's going to be N. We have an annual interest rate of 6.5%. So that means that I'm going to take this percent and write it as a decimal. So that would be dividing by 100 or moving 2 decimal places over to the left. So that's really 0.065. And we're talking about ending up with an amount of $15,000. So that's my ending point. So that's my A. Okay, so I'm going to substitute in everything that I know. Remember, we're going to try to find T. So that's why we don't know what T is. So we're going to have 15,000 to equal 7,250 times 1 plus 0.065 divided by 12. And that's all raised to the 12 times T power. All right, so we want to start solving for t. So the first thing I want to do is I want to isolate that base by itself, which means I'm going to divide both sides by that 7,250. All right, if you want, we could reduce that down. I'm really going to just leave it as it is for right now. It's not that big of a deal. So we're going to have this. That's going to now equal my 1 plus 0.065 divided by 12, all raised to the 12 times t power. Okay, so it's not the prettiest base, but we do have the base by itself. So that means we are going to take the natural log of both sides. So we'll have the natural log of this 15,000 divided by 7,250. That's going to equal the natural log of our lovely base 1 plus 0.065 divided by 12 raised to the 12 times t power. Okay, so notice that this time on the right, we don't have a base of e. So the natural log and that base will not cancel out nicely. So that means we have to follow the power rule. I'm going to move that 12t for exponent out in front by multiplying. So notice that we'll have 12 times t times the natural log of all of this. All right, so now I want to solve for t. So I think I'm going to do this first. I'm going to divide both sides by the natural log of this 1 plus 0.065 divided by 12. And then we are going to very carefully type that into our calculator. So once again, make sure that you are very careful not to lose parentheses. So hit the natural log button, 15,000 divided by 7,250, close parentheses. Then divide by natural log and then 1 plus. You might want to put that 0.065 over 12 in parentheses and then make sure once again that you close the parenthesis. So you'll divide, you'll get a big decimal, leave that big decimal in your calculator because technically then now on the right-hand side, we just have 12t. So the last step then to get t by itself is to divide by 12. So all of this that's in your calculator, now hit divide by 12. And what you should get is approximately 11.22 years. Okay, so please let me know if you are not getting that in your calculator, but that is approximately the amount of time that it'll take to get from that $7,250 to the $15,000 based off of the compounded monthly and the 6.5% interest rate. Okay, so that's us solving applied problems involving exponential and log equations.